So we're going to use the same data set. So it all starts from the same CSV file, but this time to be more efficient, we're not going to work on the first CSV file we used because for that file, we actually later on perform some operations to change that file, right? So let's look at the player revised.csv. That's exactly the same file we downloaded. I have uploaded to my GitHub again. So if you right click and copy link, and then we're going to load this new CSV file after the modification, right? So then, same thing as usual, import pandas library. It's a new notebook, so you have to import every library once again because it's the start of a new notebook, right? And then load the CSV file after the revision as a data frame and show the content of the data frame. All right, so it's loaded, right? So let's see, there are 2 missing values, and the last row is about the player Anna Martins, which is the new row I included. Now, we want to handle missing values. And we have 2 missing values for row 10 and row 11. So, I mean, this is quickly visualized if we have a small data set, right? But imagine that you have a data set of 1,000 or 10,000 rows. You cannot possibly quickly identify all the missing values. So step 1 for handling missing values is to identify them, right? First of all, let's see if there's any missing values. If there are missing values, how many? Right? So those are the questions we want to look at. Now, let's quickly see how we can do that. Okay. And the first thing we can do is to use a command called df, and that's the name of data frame, right? If you use a different name, you need to use a different, use that name for all your operations, right? So I'm going to do df.isNull. Null just means missing values. Right? So, and let's see what it returns us. Before that, let's actually first to do df again to visualize the content again. This is the CSV file content. It shows all the elements like name, nationality, and team for everything, right? So if we do df.isNull, it's going to give us a table of the same size, but the values of the table will be different. And let's see that. Right? It's a bunch of Boolean values, true and false values. We have most of the values being false. 2 values, in the first column of row 10 and row 11 being true. So why is that? Why 2 true values and the remaining values are false? Because, in the original table, in those 2 positions, column number 1 and row number 10 and 11, and those are missing values, right? And the remaining values, they are not missing values. They're just the normal valid values, right? So if you run this command, it gives you the same table by replacing all those values. If you had a valid value at a certain position, it's false, meaning that it's not null. It's not a null value, right? It's a valid value. If you see true, it means that in those positions, you had missing values. And so that's what it does for this function. Right? And that's something you can use to identify if there's any missing values. But still, it's not very easy, right? Because you may have many true false values for a large data set. So how do we quickly identify if there are any missing values and how many in each column? What do we do? We're going to do a simple arithmetic operations, and that will give us information about whether or not we have any missing values. Okay. Now, the key idea is that usually by Python and other programming languages, if you do arithmetic operations, false is treated as 0. So all those are 0 values. Right? All those are 0 values. Every false, you can consider that as a 0 value if you are adding up two Boolean values, right? But true is 1. So all being 0 except two ones, right? Because false is 0 and true is 1. And then if we do the summation across all those values in the first row, adding up all those values, right? False being 0, true being 1, we can see that we'll get 2, right? Because 0 plus 0 plus a bunch of zeros, but there are two ones among them, right? So that's how we get the value 2 if we sum up all those values across the rows for the first column, right? And then for the second column, false is 0, so everything is 0 in the second column. If we sum up the values in the second column, what do we get? We get 0, right? Because all those false values are treated as zeros. And then the same thing for the third column, all those false values are treated as 0. You sum them up, you add them up, right? It's again 0, right? So if we do this, we'll get 2 for a full name. That means we have 2 missing values in the first column, right? And then 0 values for the remaining columns, meaning that we don't have any missing values for the remaining columns, right? And this is true for this example. If you have a different example, the same logic will remain true. Okay? Now, the question is that how we can implement this. Okay? And it turns out it's quite simple. The only thing we need to do is actually based on the command we just introduced, which is df.null. Now we're going to do df.isNull and then .sum. That will perform a summation on top of the df.isNull result, right? And then by default, if you just use a summation function for any data frame, by default you are just summing up across the different rows, right, for every column. So let's see. Right? So we had 3 columns. Then for each column, we sum up those values. False is 0, true is 1. We get 2 for the first column. And then that's why full name has the result equal to 2, meaning that the 2 missing values, right? And nationality team being 0, it means that for those 2 columns, there's no missing values, right? So is now give you a table with true false values. And then .sum allows you to sum up all those values across the different rows, with false being 0 and true being 1. And that's why we get those 3 numbers to show how many missing values we have for the 3 columns. Questions? Let me know if you have any questions, but this is the way we can count how many missing values for different columns. Okay. Now, not only we need to identify the missing values, but we want to do something about it. So what do you suggest that we should do about those missing values? So what do you think? What should we do? Actually, there may be different methods, but I'm going to talk about 2 methods, which may be somehow serving a specific purpose. Right? Number 1, the player names are not important, right? Maybe you focus on the remaining information, right? Maybe the distribution of nationalities among all players, or maybe we want to see which team has the most number of players. And in those cases, player names is not that important, right? That's missing value causing some hassles, but it's okay. We just artificially replace them with something that is somehow meaningful, right? So let's do this. So first of all, I'm going to do df copy. That's a new data frame, right? So I want to create a new data frame from this function, df.copy. So it means that I'm creating a copy of the original data frame so that when I'm doing something, I don't affect the original data frame. In this case, I want to save the original data frame for a later purpose. Right? So let's create a copy of the original data frame. And of course, this is going to be exactly the same as the original data frame. It's actually a duplicate. Right? Now, what we can do is that for this new copy data frame, I want to do this. I want to do some function which is called, actually let's do this. I want to take the column of full names, because that's the column that actually has some, has some missing values, right? And then on top of this column, we have a method which is called fill NA. Okay, it means that we're focusing on the column, and further we're hoping to replace the missing values by something more meaningful. And what do? Let me complete the codes by just using the tab key, following the instruction for hints by the AI. So fill NA unknown player means that we're just replacing NA, fill the value of NA, missing values, with the word unknown player, the phrase unknown player, right? And then in place equal to true, because I want to modify this df copy data frame. So that's what we're going to do, right? So very simple. The idea is that I want to replace it with something a bit more meaningful. So let's quickly run the command. There's some warning. Sometimes things happen because whenever you are trying to modify a data frame, sometimes there's some version issues. But fortunately, it doesn't create any errors. There's some warnings, but not errors. But anyways, the purpose is served, right? So if you look at row 10 and 11, now it's not an AN, it's an unknown player. I mean, not big of a, not very much a big change, but at least resolve the missing value issue. And this is applicable if we are focusing on other important information. A name is somewhat necessary, but it's not that important. And then we can handle the missing value this way, right? Now, that's one way method, just to replace it by something that is more meaningful, okay? Now, questions? Now, there's a second method, which is also very common, but somehow more simple, right? So this time, let's directly change the original data frame, df. This time it's more direct, just a drop NA, okay? Drop all those rows so that they are gone, right? So let's say player name is a critical information, right? So without the names, for my purpose, those records is meaningless, right? And then I would prefer to drop them. So df.drop NA, it means that I want to drop all those rows with NA values. And let's specify in place equal to true, right? Because I want to directly modify the data frame, okay? And then after this operation, let's display the content of df, okay? And then let's see how it goes. All right, so as we can see, row index 10 and 11, we have missing values, they're not gone because I dropped them. Now, it's a data frame without NA values, without missing values, right? So there are two ways. Not necessarily one way is better than the other. It really depends on the purpose, right? So one potential caveat for this method is that if you have quite a bit of missing values and you drop every row with missing values, maybe the usable data amount is very small. So you don't have much data left, right? So in that case, maybe it's better to actually replacing the NA value with something that possibly may make some sense, okay? Anyways, that's how we deal with missing values. There could be more ways depending on your purpose, but we are going to cover those two very basic operations. Okay. All right. So actually, I messed up with a bit of the relationship between comments I used and the operations. I'm going to fix them after today's class. So you'll have something more clean to read. But anyways, let's move on for now. Now, we want to handle duplications as well. We have a lot of duplicates, and what do we do about them? Okay. Now, what is duplication? I mean, a simple way of duplication, a simple way of defining duplication is that, if two rows are identical, right? And then we have duplicates. Now, if you look at this closely, indeed we have two rows that are exactly identical, right? So row index 7 and row index 12, the last row. Actually, I intentionally added this last row in the previous notebook. So those two rows are literal duplicates. They are exactly the same for every column. Right? So this is very easy to deal with. Let's see how we can do that. We can just simply actually drop those two rows. Let me find a cell to work on it. Right? We can simply drop it. So it's df dot drop duplicates. And actually, most of the commands are very intuitive. Right? So nothing complicated. df dot drop duplicates in place equal to true because after dropping the duplicates, I have modified the data frame. I want to directly modify the original data frame once again, right? And then let me include the name of data frame in the bottom to display its content again. And then let's run it. As we can see, now the redundant row is actually gone, right? So it's actually, Anna Martins is in row index 7, row index 7. That's the only row without any duplicates, right? So, sorry. Let me phrase it a bit better. So we have two rows with the same information as row index 7. Now there's the other redundant row is gone, right? All right. So that's how we can drop simple duplicates. But we still have a problem, right? So, because as we mentioned, there are some slightly more complicated duplicate records, like row 0 and row 1. They look like duplicates, but they are not literal duplicates because one of them has an accent, even though most likely they are the same person. So what do we do about that? I mean, we cannot use this simple drop duplicate function here because it doesn't work, right? They are not literal duplicates. So what do we do? And this time, the method we can use to handle those duplicates that are more complicated is that we can do some normalization. Okay? And let's see how we can normalize all those functions. All those strings, string values, textual values, right? So first of all, we need to observe that in our data set, one way that we have variations is accents, right? So if you accent on top of a letter, that's a form of a possible source of duplication. Okay? And then other than that, it's not in our data set, but possibly we may have some redundant white space, right? So let's say in some records we have two spaces between the first and last name. It's going to be treated as a different value, even though they're going to be the same person, right? And then sometimes there may be some problems created, like uppercase and lowercase appeared, or the same letter appeared in two different records. Right? They're the same person, but then mistakenly maybe you use the lowercase for the family name, and turned out they are different values, but they're still duplicates. Right? So those are the three common sources of duplicates, and let's do some normalization to address it. Okay, so let's see how we can do this. This time we're going to use an example, and first of all, let me install and include a library we're going to use for the purpose of doing some normalizations. And one library we're going to use is called unit decode. So let's do this. So from unit decode, I want to import a module of the same name, okay? And this is going to be used mostly for me to remove all the accents in the example. But if you run the cell, there will be an error. Let's see. If you read the error carefully, it says there's no module named unit decode, right? I mean, that means the unit decode library is not available, right? And the reason it's not available is that it's not installed, right? So let's install it first. So there's a online huge repository of all the Python libraries. So it's usually the commonly used ones are including Colab or Anaconda and some commonly used distributions of Python, but not all of them, right? So if we want to install it, we can do this command. It starts from the exclamation mark because it's not a Python command. It's a shell command. It's like your operating system has a command line. That's the command from the operating system. So if you put exclamation mark before it, you can run it and visit a notebook. PIP is the package management system of Python. So PIP install unit decode. That will help you install the unit decode library, right? Just one more step on top of what we usually do. And then let's run it. So basically, Colab is a virtual computer in the remote server. So we can just do similar things like installing packages and other things, like as if you're using your local computer. Right? So it's downloading and installing and successfully installed. And now it's also actually imported as well. Now let me comment out this installation command, because every time we have the Colab notebook being active, we only need to install it once. Next time, if you are timed out and you have to start the Python kernel again on Colab, you have to install it again. For local computer, you just install it once for lifetime, right? Unless you uninstall the distribution of Python entirely from your computer. All right, so let me comment this out, and then we're gonna define a name. Let's say name equal to something like Andre, but let me see how we can type this. So it's actually a bit difficult to, I find a way to type the accent. Andre, let's say Marx, okay? So any name, but I'm gonna intentionally create some problems. Right? For example, there's a leading and trailing white spaces. There's also two white spaces, two spaces between the two names, and there's the accent problem. I want to normalize it, right? So in the end, I want to convert it to something that is standard without accent, without extra white spaces. So let me first run it, and I want to have the name variable displayed. So let's run it. So the result is Andre Marx, right? With the accent, with extra white spaces. And then we're going to do something about this name. First, we start by removing the accent, right? So that's sort of more normalized for the purpose of further comparison. Now, this time it's going to be very easy. Let's do name equal to unit decode name. So unit decode name is going to remove the accent. And that's the function we just imported from the unit decode library we just installed, right? And then we assign it back to the original variable name to override it. And then let's look at it. Now it's Andre Marx without the accent, right? So we remove the accent, which is great. I mean, for the purpose of standardization, right? Next, there's the extra white spaces. So what do we do about the extra white spaces? Again, we need to do something about the name, right? So this time what we can do is that we're going to do name.strip. Name.strip is nothing but to removing any leading and trailing white spaces. So let's run it. As we can see, the leading and trailing white spaces, those spaces in the beginning and the end, they are removed, right? So let's assign it back to the original variable name. And then you can visualize the value of name again. So it's 100 marks without the leading and trailing white spaces. But we still have 2 white spaces between the first and last name. Right? We have to do something about that as well. So let's move on to remove the extra spaces between the first and middle name. And this time, we're going to use something that is maybe slightly advanced. But I mean, with all those AI functions, it's actually not that difficult. Actually, if you included a comment like this, it's recognized by the AI assistant. It's already helping you to complete the necessary codes to fulfill the task, right? So let me first actually complete the codes, and then I will quickly explain what does it mean. So import RE. RE is a regular expression, and those are for you to identify patterns in textual information. And then not only want to identify pattern, for example, when I say pattern, 2 white spaces or even more white spaces between 2 words is a pattern, right? It's a pattern we want to fix. Not only want to recognize this pattern, but we want also to replace the parts of a text that matches this pattern, right? So let me quickly explain what happens in this command. So what we have here is that, first of all, we have name as the last argument for this function, re.sub. Sub means substitution, right? We're going to substitute a certain part of the string that matches a certain pattern with some given values, right? So this is the string I want to work on. And then the first argument includes a string that represents a pattern. So \s in regular expression, that means white space. Okay, so that's white space. And then you see a plus sign. Plus sign means one or more occurrence of the white space, right? Once white space, 2 white spaces, 3 white spaces, as long as there's at least one, they are all matched by this pattern. Right? So \s plus is 1 or more white spaces. Okay? And this is the pattern we want to recognize. Now, why do we have this R before the quotation marks? Right? We have single quotation marks, but in Python, most of the time, single or double quotation marks are the same. Right? No difference. So remember, previously we have something called F string, which defines a particular kind of string. Now we have R string. R string is raw string for Python. And we don't have to worry too much about that, but let me quickly explain. Okay. So basically, /s is representing white spaces by regular expression. However, when the Python interpreter sees slash something, it always tries to interpret as some special kind of character. Right? So then if you don't treat it as a raw string, there's a conflict between the interpretation of Python and interpretation of regular expression. Right? If you add R, which is typically recommended for any regular expression operations, what happens is that you're telling Python that don't try to interpret slash followed by any character or any special characters like the $mark as some special meaning characters. Okay? Instead, just do it literally to give it to regular expression, right? And then everything will handle by regular expression, right? So if it's a bit confusing, that's okay. You can. If it's confused, then what you can do is to provide a comment or prompt like this one, and then the AI will handle things automatically. And if you do it many times, you will get a feel. Okay. Now, in the middle part, the middle argument, we have another string, which is the string I want to use to replace the pattern, right? So in the middle part, what we have is just a single space, right, between quotation marks. So what does it mean? It means that we're replacing one or more white spaces with one single space in the string variable name. Okay? So now this will remove the extra white space between the first and last names. Okay? Now let's quickly run it and see if it will give us the desired result. Now, quickly compare with the previous case. Andre marks the two white spaces between the first and last name, and now there's only one white space, right? I mean, the regular expression simply serves the purpose of match more or more white spaces and replace it with one single white space in the variable name, okay? So that's how it works out. Now let's quickly complete this example before we have the second break. Now let's define a function that performs all the previous operations. Remember, we first remove the accent, and then we remove the leading and trailing white spaces, and then we remove any white spaces between the first and last name, or actually any two words. Okay. Now, to save some time, this time let me just let actually AI handle it. Right. So very simple. We're actually exactly that defining a function that takes a name or any word or any textual input, and then unit equal, stripping the extra spaces, use regular expressions to remove the internal white spaces, and then return the name after this bunch of operations. I'm going to do one thing, right? So instead of directly return the name, let's actually do name equal to name.lower, and this is converting the name after normalization to all lower cases, right? And then I return the name. So let's define this function. Let me run this function, okay? And then we can quickly check if this function works or not, right? This function is called normalize name. So let's do a function called normalize name. And then let's use it on the original name we used with white space and accents, right? So let's see if it serves its purpose. Looks like it's okay, right? So it's remove the accent, white space, and convert everything to lower cases. Now, in the original data set, if I normalize all those values, and then some of the non-duplicate values will become duplicate values, and then we can drop them. So we define a function that takes a variable that is a string, let's say a name, but it doesn't have to be a name, okay? And then inside the function, we first remove any accents, and then we remove any extra white spaces, and finally we convert everything to lowercase. And then we throw out this modified string as the output, right? And we test it on this name 100 marks with extra white space and with accent, and turns out it served our purpose. All right, so now we're going to go back to the original data frame, and we want to apply this function on the name column, right? Because as we can see, the redundancy or the duplicates are in the name column. Before we can remove those less trivial, complicated, duplicates in the name column, we first need to standardize them. Right? So, for example, Diego Alvarez with or without the accent, they should be converted into the same format so that we can recognize it's a duplicate. Okay, so this time we're going to work on the name column. Right, so let's take a look at the name column, full name, and run it. Of course, we get the name column, right? And we need to do something about the name column. So what do we do? Exactly the previous function, right? Normalize name. But there's one problem. Because this normalize name function takes an input that is a string. And that's why we can perform all those string operations on this input, right? Now we want to apply it to this whole column, but this whole column is not a string. Instead, it's containing many different string values. Right? So how do we do that? We cannot just directly apply normalized name, parentheses, df full name, because that's not a string. Instead, if we have a column of strings, we want to apply the function to every single string value in that column, we'll do this. We'll take the column first, and then there's a method provided by pandas for applying a function that is applicable to the elements of the column. Right? So apply, and then inside this apply function by pandas, I provide the function name I want to apply, which is normalized name. Exactly the same function I have defined just a few moments ago. Okay, so it's take the column and then apply the normalized name function on this column to get the normalized values. So let's do this. Let's run it, and then we see that now all those names are normalized. And now clearly we can see row 0 and row 1 are duplicates, right? And then to make it just a bit nicer, let's do this. Let's create a new column, df. New column name can be something like normalized name. Assigning this column of values to a column name that did not exist, that creates a new column, right? And after I've done this, I will again visualize the df, the data frame content again. So let's do this. Now, we first created the content of the normalized name column and assigned it as a new column, right? So now we have this modified data frame where we have the normalized name column. And then to recognize any duplicates, we're going to focus on the last column, the new column, right? But then how do we actually go ahead to drop any possible duplicates? How do we do that based on the last column? One thing we can do is to use the drop duplicates function. There's a slight twist, right? Because if you look at this this data frame, compare all those rows, row 0 and row 1, they're still not duplicates, right? Because at least for one column, they have different values, right? However, if you ignore the full name column, the original name column, and focus on the remaining columns, you can recognize that they are actually duplicates, right? So the next thing we can do is that we're going to create a new data frame. Let's say df underscore nn for normalized name, nn for normalized name, right? So then what we can do is that we can do this. We can do df, and we're going to select only the column of normalized names. So let me complete the command first and let you know, and then let you know what does it means. Okay. So now on the right hand side we have df square brackets, meaning that we're selecting some columns, right? And we're providing a list of column names. Now if you want, you can include multiple columns, but for demonstration here, I'm only including one column, which is the last column. And that makes it a new data frame with only the last column. And then let's quickly visualize it. Sorry. So let me do this. Just somewhere. Okay, so let me quickly check if I have the right name. Anyways, so maybe I can do this again to explain the error. All right, so let me remove this first. This time it actually worked, so I'm not sure what exactly happened. But anyways, must be some minor errors or typos. Okay, so now I'm taking only the last column from the previous data frame. So it's a data frame of single column, right? Then df and let's see what's the content. Only the last column, right? But based on this column, I can identify the duplicates, right? Because apparently 0 and 1, they are duplicates, right? And if you look at the remaining columns, it looks okay for now. There's not any further duplicates. But still, after this operation, we'll still have some remaining issues. But let's work on this first, okay? So now, for this new data frame with only one column, let's do drop duplicates, right? So then I will get the duplicates dropped. So let's just return the result. We don't need to have in place equal to true here. And let's see what happens. All right, so let me actually do one more thing so that we can do a quick comparison. Display in the middle, if I want to display the original data frame after including only one column, I need to display it. And then further, the command after dropping duplicates show me what happens after dropping the duplicates, right? So the only change you can see is that 0 and 1, they are duplicates. Now after the dropping duplicate operations, the second row, the row with index 1 is gone, right? Because that's recognized as a duplicate. Now we can focus on the indexes of the second data frame, right? As we can see, it's not continuous because we dropped one record. But this time, let's take all those indexes from 0, jump to 2, and going forward, right? So after dropping duplicates, we get a data frame. Let's take its indexes. So dot index, that will give me the index, right? So this is the displaying the single column data frame with duplicate. Now, after dropping duplicate, we can see that the remaining index, the index of the remaining rows not dropped, is actually 0, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now, this gives us an important piece of information. So what do you think it gives us? It means that those are non-duplicate rows, right? According to the kind of operation we were performing. So take 0, row 0, skip row 1 because that's a duplicate, and take 2, 3, 4 until 9. And those are the indexes that of the original data frame that are not duplicate rows, right? So this is something useful to me. So let's say non-dup IDX. So I'm calling this non-duplicate indexes, right? Now, after getting this non-duplicate index, I'm going back to the original DF, right? Original DF, remember, that's the whole data frame, okay? But this time, what we can do is that we can take we're going to take only those non-duplicate rows. Right? So I'm going to use df.log because that takes rows, right? And then which rows are I going to take? Well, that's the non-duplicate row indexes, right? Which we obtained after dropping the duplicate rows. And then this one is going to give us a data frame, that removed the duplicates after normalization. Okay. So let's do this. DF, let's call it DF dedup. So that's the data frame after deduplication. And then finally, let's enter the name of this new data frame to show its content. Also, let me comment out this intermediate step of visualizing the one column data frame. All right, so that's the final result. As we can see, we have row 0 and row 1 being the same person. Now row 1 is gone, because after normalization, we have the same normalized name. So we drop one of them, which is typically the second one. Right? This first one is kept by default. And then I took the indexes of the rows that are considered as non-duplicates. And then I use this index to retrieve the corresponding records from the original data frame DF. Okay. And finally, this gives me another new data frame which without the kind of duplication we want to remove. Questions? Is the logic clear? I guess it's maybe slightly confusing because let me quickly explain this again. Okay, so what happens is that we have a data frame, right, and then we take only the last column, which is the normalized name, right? We only take this column. Okay, after taking this column, I want to check. After this column, I want to check. I want to drop the duplicates, right? So let's. This is the new one column data frame. So let me run it again. So now, focusing on this one column data frame, I removed one duplicates because they have the same normalized name. So one record is gone. Right? Now I focus on what's remaining, right? From 0, 2, 3, that's the remaining indexes. So I just use .index for this result data frame. That will give me 0, 2, 3, those rows that are not considered as duplicates. Right? And then I just called it non-dupe index. Okay. Now I got the non-duplicate record index. I go back to the original data frame. I use .log because I want to take rows. But which rows do I take? Well, it's going to be only the non-duplicate indexes are obtained. Now the record 1 is gone, right? So finally, I assigned it back to a data frame variable name called df dedupe. And then we can type the name of the data frame after deduplication to visualize its content. Right? So that's how it works. Questions? I mean, we can certainly discuss after class if you have any questions about that. But anyways, this is slightly complicated than the previous examples. But hopefully the logic is clear, right? We just created the new column, which is the normalized name. Now, after normalization, some of the similar names become the same name because they are meant to be the same person, right? And then this allows you to recognize duplicates and drop the duplicate records in this new column. And in the same time, you can keep track of which row we dropped, right? And then you go back to the original data frame and drop that row as well. Okay. All right, so then let's do one more step, and this is to be used for the subsequent notebooks for future classes. Right? So we have the df dedupe with the duplications removed. So let's see it again. Okay. Now, just to save it to a CSV file, and we can, for consistency, the file we want to save is going to be named as cleaned, players _ cleaned.csv. Right? And index equal to false because we don't want to save the index values in the CSV file we are going to create. And then run this. And then the CSV file should be already created. You can download it manually, or if preferred, you can again do import the Google Colab call a file module to download a file. So the same thing as before. So let's directly complete that, right? So then the file is downloaded, and the task here is completed. Okay, so this is the end of the second notebook we used today. The purpose is, to handle some missing values and also try our best to remove some duplicates. But of course, if you go back to see the data frame after deduplication, we'll see that there's still some problems, right? For example, row 5 and 6, there may be a typo in the last name of row 6 in the player's name, but again, because of typo, we have to duplicate results, and we still need to work on how to remove those.